Hi, my name is Ruben Garcia,
And my name is Victor Aguilar.
and we are going to talk about the zero law of thermodynamics. Well, to understand the zero law of thermodynamics, it's very important to you know this. Imagine that you have two objects at different temperatures. In this case, we have one at 7 degrees Celsius and another one at 50. These two objects are separated. Then you connect both objects and they start to transfer energy. This is what is called energy transfer. After that, the energy will continue to transfer until the two objects get the same temperature. This is what is called thermal equilibrium. Then, if the two objects are in thermal equilibrium, when a third object comes in, these objects also become with the same temperature, or thermal equilibrium. This is what we call the zero law of thermodynamics. Well, now my partner is going to give you an example of this law.
Then I will give a simple explanation of what is the zero law of thermodynamics. Imagine that we have these three items. We have one spoon, one glass with water, and some juice of lemon. Imagine that the glass of water with a temperature of 15 degrees Celsius, and next we put some juice of lemon with 0 degrees Celsius. Next, we add this juice to the water and they will become into a thermal equilibrium, and obviously they have the same temperature. After that, we add the spoon to the mixed water and the juice. This spoon will become with the same temperature as the two objects added at the beginning, and this is what is known as zero law of thermodynamics.
Hi, I'm Barbara Puga,
And I am Larissa Contreras.
and we're going to explain you about the first law of thermodynamics. For this law, we are going to refer U as the internal energy. We get this by summing the kinetic energy and the potential energy of the molecules. For the first law of thermodynamics is usually formulated in the context of a gas that is contained in an enclosed container. Its equation form looks like this. Delta is referring to change. Then U refers to the internal energy, and this is equal to Q, that is the heat entering the system, minus the work done by the system. Something you'll see a lot when doing thermodynamics involving the first law are the PV diagrams. P for pressure and V for volume. What this means is we have a container full of gas, and there is a movable piston that can go up or can go down. And this will change the amount of volume. This is the volume we're talking about. And that would change the amount of pressure. So we start with a certain amount of volume. And if you put the piston down, the volume will decrease. But if you put the piston up, the volume will increase. So in the graph, the volume increases if it goes to the right and decreases when it goes to the left.
So here's an example. Remember that y-axis is pressure and x-axis is volume. So according to this, we have to calculate the work between the points A and B. And how are we going to do that? We can make two different shapes. Here we can see a triangle, and downwards is a rectangle. If you can remember, the formula for area of of any triangle is b multiplying h divided by 2, and for the rectangle is b multiplied by h. And we're going to start with the triangle. Base is from 0.7 to 1 means that there are 0.3 units. So they are multiplying the height of this triangle, that is from 200 to 340. So this means that from height is 140 units. And this result, we have to divide it by 2, and the result is 21 units. And we are missing this shape. For the rectangle, the base is 3 multiplying 200, and the result is 60. In order to get the result of this, we have to add the both results that we have. So the work done from point A to B equals 21 plus 60, and this results 81. And the units, this is really important, the units for work are kilojoules. If you have any doubt, you can ask Teacher Berta. She's a really good teacher. Thanks for watching.